Hello everyone, this video is for Mman2300 Assignment D. I will introduce the plane kinematics and the kinetics of rigid bodies today. For the kinematics of the rigid body, the plane motion of a rigid body may be divided into several groups. There are translation, rotation, and general plane motion. The translation is the motion that every line in the body remains parallel to its original position at all times. There is no rotation of any line in the body. The rectilinear translation means the motion with all points of the body are in parallel straight lines. By contrast, in curvilinear translation, the path of the motion of the particles are curved line. The rotation about a fixed axis, is the angular motion about the axis. The rotation means in a rigid body, all particles move in circular paths about the axis of rotation, and all lines in the body which are perpendicular to the axis of rotation rotate through the same angle in the same time. The general plane motion is the combination of the translation and the rotation. The figure shows the example for each type of motion. The kinematics of the rigid body is the study of the geometry of motion. It describes the motion of bodies without reference to the forces which either cause the motion or are generated as the result of the motion. It is used to relate position, velocity, acceleration, and time without reference to the cause of the motion. For the kinetics of the rigid bodies, it's not the same as the kinematics of the rigid bodies. The kinetics of the rigid bodies is the study of the relation existing between the forces acting a body, the mass distribution of the body, and the motion of the body. It is used to predict the motion caused by given forces or to determine the forces required to produce a given motion. There are some general equations of motion. The first one is the resultant force of the external forces acting on the body equals the mass m of the body times the acceleration a of its mass center g, which is the F equal to m times a bar. And the second one is the moment equation taken by the mass center. It is the resultant moment about the mass center of the external forces on the body equals the time rate of change of the angular momentum of the body about the mass center. And the third one is just a change of the equations. With the third equation, we can get the final equations, which is the sum resultant force equal to the m times a bar, and the moment of the g equal to the I bar times alpha. As I have introduced the plane kinetics of the rigid bodies, now I will do an example of the kinetics of rigid bodies. The 1500 kg pickup truck reaches a speed of 50 kg per hour from rest in a distance of 60 meters up to 10% incline with constant acceleration. Calculate the normal force under each pair of wheels and the friction force under the rear driving wheels. The effective coefficient of the friction between the tires and the road is known to be at least 0.8. First, we are going to find the acceleration of the trunk. Use the equation that v squared equal 2 times a times s. So the acceleration of the trunk is 1.608 meter per second square. Then, to solve the problem like this, the free body diagram is the most helpful tool. We analyze the force applied on the trunk. There are 5 forces. one normal force applied on point A and a normal force applied on point B. Also, there is a friction force on point B. Otherwise, from the gravity force of the trunk, the force divided into two forces, W times sine theta and W times cosine theta. All of these forces are equivalent to the mass times acceleration. The magnitude of the resultant force, which is mass times acceleration, is 2,410 Newton. So we know the resultant force of the system is 2,410 Newtons. Then we apply the three equations into the system. First one is the resultant force in x direction should be the same as the mass times acceleration in x direction. We get the friction force is 3,880 Newton. Then we do the y direction. And we got the equation n1 plus n2 minus 14.64 times 1000 equal to 0, and we make it equation A. Then the total moment should be 0 as well. So we get 1.5 n1 plus 3,818 times 0.6 minus n1 times 1.5 equal to 0, and we make it equation B. Solve the equations A and B. We can get the n1 equal to 6,550 Newton and n2 is 8,100 Newton. The next step is to check the coefficient of friction. We got the friction force is 3,880 Newton, and the coefficient of the friction mu is at least F divided by N2, which is 3,880 divided by 8,100, that is 0.48. Since the coefficient of friction is at least 0.8, so the surfaces are rough enough to support the calculated value of F, so that our result is the correct one. This is the presentation for today. Thank you for the watching.